Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 2nd, 2026, just yesterday. It introduces a dual-agent framework that uses a standard file system as external memory to bypass context window limits, achieving state-of-the-art results on deep research benchmarks. The paper is titled FS Researcher, Test Time Scaling for Long Horizon Research Tasks with File System-Based Agents. And, as we'll see later, this approach of decoupling information gathering from report writing enables some really impressive scaling capabilities. Figure 1 illustrates the core problem with current research agents and how this new framework solves it. In the top panel, we see the standard single-agent pipeline where the model's limited context window quickly fills up with raw observations and reasoning steps, squeezing out space for the final report. The middle panel shows a common workaround where observations are compressed to fit more in, but this is still ultimately bounded by the hard context limit. Finally, the bottom panel presents the FS Researcher approach. Instead of trying to fit everything into memory, it uses an external file system workspace of unlimited size, allowing the agent to spin up multiple sessions that read and write to this shared storage. So, Figure 2 breaks down the specific architecture of this dual-agent system. It starts at the top with a high-level research task, for example, analyzing global insurance companies. On the left, we see the context builder, which acts essentially as a librarian. It uses web tools to iteratively search, read, and archive raw data into a structured knowledge base. Then, on the right, the report writer takes over, drafting the final document section by section by pulling facts from that archived knowledge. Underlying both agents is the file system workspace at the bottom, which stores the actual files, like the report draft and the knowledge base, along with control files that track progress. Alright, Table 1 lists the specific toolkit the agents use to interact with that environment. The top section covers the file system tools, which function like standard command line utilities. Agents use ls to list directories and grep to search text, alongside read file to access content. Crucially, they can edit documents using insert, delete, or replace, enabling iterative refinement of their notes. Then, the bottom section lists the web browsing tools, search web and read web page, which fetch external information. Transcript. So Table 2 details the performance on the deep research bench. The top rows show proprietary models like Gemini 2.5 Pro and OpenAI Deep Research, which score between 45 and 49. In contrast, the bottom section reveals that FS Researcher with Claude Sonnet 4.5 takes the top spot with an overall score of 53.94. This significantly outperforms the previous best open source system, Rhino Insight. Most notably, the high score of 55.85 in the Insight column suggests that the file system approach successfully enables the deeper reasoning required for complex research. Annotations. Table 3 shifts the focus to the Deep Consult benchmark, which evaluates performance on real-world consulting tasks. Comparing the categories, FS Researcher consistently outperforms the competition. In the bottom section, the Claude Sonnet 4.5 version achieves a dominant 80% win rate and an average score of 8.33. This is a significant jump over the proprietary Gemini 2.5 Pro Deep Research model in the top section, which manages only a 61% win rate. Alright, Figure 4 investigates the system's test time scaling capabilities. The left panel shows that as we allow the context builder more execution rounds, the knowledge base grows steadily, with source files and citations accumulating from 3 to 10 rounds. This extra data directly boosts the final report quality shown in the right panel. Metrics like comprehensiveness and insight rise consistently with more rounds, although readability actually dips slightly after 5 rounds, suggesting that excessive context can eventually create verbosity. Wrapping up, the big takeaway is that FS Researcher effectively bypasses context limits by treating a standard file system as durable memory. This separation of evidence gathering from report writing enables genuine test time scaling, where more compute directly yields better insights. It suggests that externalizing state into structured files is key to unlocking PhD-level autonomous research. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.